In this lesson we'll be talking about implicit differentiation, and our equation here is in implicit form, and so we want to take the derivative of it, and this is how it works. So we take the derivative of x squared, which is 2x, and the derivative of y squared, which is 2y, and we're going to tack on now a dy dx. Every time we take the derivative of y, we will be tacking on a dy dx next to it. The derivative of 5 is 0. Remember, the derivative constant 0. Now what you want to do is solve for dy dx. So I'm going to take the 2x over, gives me negative 2x, and then multiply both sides by 1 over 2y. Or you can think of taking the 2y and bringing it diagonally down in this direction. And then we want to simplify this down. So we cancel the 2's out, and we're left with negative x over y is equal to dy over dx. Okay, in this problem we have x times y is equal to 10. And we're going to be using the product rule here. So we take the derivative of x times y, rewrite the second, plus rewriting the first, and then you take the derivative of y, and the derivative of y is just 1. But remember, we have to write dy over dx every time we take the derivative of y. And then the derivative of constant is 0. Then you want to solve for dy dx. And I take the y over to the right hand side, gives me negative y, and then multiply both sides by 1 over x to both sides, and we're left with negative y over x. In this function here, or in this equation I should say, we have x over y squared is equal to 10. Now I'm going to be using the quotient rule here, and taking the derivative of the top, which is 1, rewriting the bottom, minus the top, times, and take the derivative of y squared, you get 2y. And now your eyes aren't playing tricks on you. I had to put a y in here. I forgot a y. Okay, and then the bottom squared. So y squared squared. And let's see, what do I do here? Well, if you take the denominator, if you multiply both sides by y to the 4th power, y to the 4th times 0 is just 0. And so you can see that's the reason this just pretty much disappeared down here. Alright, and then let's see, just rewrote, kind of cleaned it up a little bit. Then we want to solve for dy over dx. So I took the y squared to the right hand side, which gives me negative y squared, and then took the negative 2xy diagonally down, and then I just simplified it. Negatives in top and negative bottom cancels out. Let's see, we have 2 y's in the top, 1 y in the bottom, so we can cancel the y out in the top and the 1 out in the bottom, and we're left with y over 2x.